Let's talk about insert next. Just like search, we'll create a recursive function, insert, that begins with a similar process of navigating to the correct location. In this case, that correct location is the empty leaf node in the tree where we would want to insert our target value. However, unlike search, insert is not a simple case of returning a value, so our recursive calls are going to look a little different. Let's zoom into each subproblem so we can see what exactly is happening at each level of function call. After calling insert on the empty child of 25, we arrive at the location where the node 26 should be located, but there isn't a node here quite yet, as nodes with no children instead just have a null placeholder value. This is our base case, and our solution here will just be to create a new node entirely that stores the value that we want to insert. We have to do something with this node, so let's return it. Going back one call, we are at the node 25 when we called insert on its right child that was previously empty. This call to insert resulted in a new node being returned, the node containing 26 that we just made. What we want to do now is update the right child with the result of that function call. So we'll set our right child to the result of our insert call that was just returned to us. This is what we were referring to earlier when we mentioned that we cannot simply return our results like we did in search. At each function call, we are effectively making a brand new subtree, albeit with a small tweak of one new node. So just like we did with the base case, we have to return our root node, so that whatever node called insert on us can properly update its child with this new subtree that we've made. Taking a step back to node 20, it called insert on its right child, node 25, and now it must update its right child to the result of this insert call, which is a new subtree that also contains 26. This happens one more time at the original true root, who called insert on 20, and must now update its left child to the result of the insert call on 20. As you can see, we still have the same recursive structure, a base case and a recursive case, but the semantics are a little different. In our base case, we are returning a brand new node, which is basically a tiny subtree of its own. To compensate, in our recursive case, we need to update each child that insert is called on, since a brand new subtree is being created and returned by each call to insert.